Okay. So in last class, when we talked about what we have studied in last class, okay, so first we will have a small revision, what we have studied in last class, okay, then we will play Kahoot quiz, then we will solve some problems. Okay, everyone, right? So today we are going to complete this chapter, and tomorrow, if you guys do well, okay, right, then we will study something extra and start new chapter. Okay, everyone, which chapter is going on in school? Which chapter is going on in school? Heat only, na? Okay, so all of you finding heat easy? Tell me, all of you finding heat easy? Okay, and apologies, I still haven't sent you the paper. It is already corrected. Okay, but there was some issues. That's why I was not able to send you back. Okay, so I'll just send it this week. Okay, okay, and this coming Tuesday you will be having test of acid and bases only. This chapter only. Okay, right, everyone? Okay, so let's start this chapter. Now, when you talk about this chapter, acid and bases, what we studied? First of all, we should know that what is acid, what is base, right? So we studied the basic definition of acid and base, right, everyone? We studied the basic definition of an acid and base. Okay, what was an acid? Tell me, what is an acid? Everyone, what is an acid? That is the property, Ragini, right? Yes, very good, right? So acids, okay, especially the acids given by the scientist Arrhenius. Okay, see, I have explained everything. I've told you to make notes, right? Okay, so see, acids are compounds that can give H plus ions on dissociation. Yes, agree? How many of you remember this? So acid is your compounds which will give H plus on dissociation. For example, HCl, HF, HI, right? Everything is your acid. Okay. Now we studied what is ion. Charged atoms or molecules. Charged atoms or molecules are called as ions. Okay, so if we have positive charge, then it is called as cation, right? See this? Positively charged ions are called as cations. Yes, very good. And negatively charged ions are called as anions. Yes, everyone? Right? I hope all of you remember, all of you watch the videos again. So examples, there are few more examples of an acid which is HF, hydrofluoric acid, H plus plus F minus. H2SO4 gives 2H plus plus SO4 2 minus. Right? So we discussed what is a cation, what is an ion. Now what is base? So according to Arrhenius, base is a compound which gives OH minus. Okay, base is a compound which gives OS minus. Okay, right? Okay, yes, very good. For example, right, NaOH gives Na plus plus OH minus. So it is releasing OH minus. So this is your base. So we discussed examples. Okay, right? Now, see this H2O, right? H2O. So I said H2O gives both H plus and OH minus, right? Okay, so it is neutral. It is neutral, right? So what's the meaning of neutral? Neutral means neither acid nor base. That's the first point that you have to remember. Agree, everyone? Right? Now, after this, we discuss the properties of acid and base. Yes, everyone, we discussed the properties of acid and base, right? The first and foremost property that we have to know is the taste, right? So acids are sour in taste, whereas bases are bitter in taste. We discussed some other example of acids, right? We have a table in your textbook, right? Lactic acid, citric acid, acetic acid, right? So all those acids, right, have sour taste. Then bases, we have bitter taste. Bases have bitter taste, right? Common bases or common component which bases are present are baking soda, detergent, soap, and all those things. Okay, now we can say that acids are sour in taste, bases are bitter in taste. But obviously, it is not possible to taste each and everything, right? You can't just keep testing everything now, right? So obviously there should be some method to identify which is my acid, which is my base. So in order to do that, we have substance called as indicator. So what is an indicator? Indicator is a substance which can identify an acid or base by changing either color, right? So for your textbook, it is changing color only, right? But it can identify by changing color or smell, right? Okay, so indicators are of three types. Indicators are of three types. Yes, very good. Natural indicators, synthetic or man-made indicators, and olfactory indicators. Okay, right? Olfactory indicators are the indicators which will change its smell. Okay, right? Very good. So natural indicators come from nature directly. For example, turmeric, litmus paper, okay, red cabbage. So those are your natural indicators. Okay, so natural indicators changes its color when brought in contact with acid or base. For example, litmus paper. Litmus paper, we get the dye from your lichens, right? Lichens, and the color of dye is, tell me, it's violet, right? Okay, but it is your red in color in contact with acid and blue in color in contact with base. So you remember like this, blue base, right? Because people get confused. So remember this, litmus paper, blue base, blue in base, right? Blueberry, blue base, okay? Like that, okay? Now synthetic indicators, we studied that synthetic indicators are man-made indicators which are made in laboratory. For example, phenolphthalein, methyl orange. So in last, we talk about the changes. Okay, so there's a table in which it is given that what will be the color of indicator in presence of acid and base. So this you have to remember. This you have to remember. Okay, so this is what we studied in last class. Yes or no? Yes or no? Agree? Everyone got the concept clear? Right? Okay, very good. Now, today we are going to study next concept, right? That is your neutralization. Okay, neutralization. Okay, so first of all, what is the meaning of neutralization? What is the meaning of neutralization? So, reaction. It is a reaction, by the way. It is a reaction between between an acid and and base to give salt and water. Salt and water. This is your neutralization reaction. Okay. So in general, you can write like this. Base plus acid. Base plus acid gives salt plus water. And this is not your normal salt, right? The type of compound is called as salt. Okay. This is your neutralization reaction. Neutralization reaction. Okay. Right. Now, you should ask, what is the use of neutralization reaction? Okay. Now, sometimes acid, okay, is harmful. It corrodes things. Okay. right? Yes, like detergent or anything. Okay, so obviously I have to do something. Okay, right? So in that case, wait, someone is asking about login. Okay, right? So in that case, we react acid with base because it will cancel out each other's property. Okay, that's the meaning of neutralization. Okay, right? So let's see everyone. Okay, okay, right? See this. Okay, sorry, I guess someone is asking about how to log in Zoom. Can just someone just message in the group how to log in Zoom? Okay, because someone is asking me, right? So that's why it's creating disturbance. So can anyone just message in the group how to log in Zoom? Okay, right? So yeah, so neutralization. So we studied. Just think about your litmus paper. Okay, right? When you talk about acid, okay, or when you talk about base. Okay, now litmus paper, just think about this. When you take your blue thin litmus and dip it into acid, what will happen? Tell me. If you take your blue litmus and dip in an acid, what will happen? Tell me, what will happen? It will change its color? Yes or no? It will change its color? Yes, very good, right? And the same thing will happen if you if you take red litmus and dip it into base. Makes sense? So what happens here? What happens here? Tell me, right? If it's changing colors, so there must be some neutralization reaction, right? Okay. Now take one more example. Take one more example. Okay. See this, right? You have acid here. Just imagine, right? Just imagine you have acid. It will be red in color. Okay, yes or no? You will have an acid, okay, and litmus paper. It will be your red in color. Okay, now try to add base slowly. Okay, right? Try to add base slowly. What will happen? What do you think? Right? Drop by drop. Okay. Now this process is called as neutralization, or there's a term, right? There's a fancy term. I'll just write it down. Okay. It's called as titration. Titration. Okay. Right? So what we have? Either we have acid or base. So here I'm taking acid. Just imagine, right? Here we are taking acid, okay, plus some indicator, right? Okay, why we are taking indicator? Because we should know now that this is your acid, okay, right? Now, Suppose it was your acid. Okay. No, I just said I'm explaining, Manita. Okay, I'm explaining, right? I'm saying suppose we have an acid. Okay, we have an acid plus some indicator. Okay, acid and some indicator, right? So it would be red in color. It would be like this. Yes or no? Tell me. Initially, if you don't add anything, if your acid plus indicator, it will be red in color. Okay, right? Now start adding base one by one, drop by drop. Start adding base drop by drop. Okay, now the indicator here used, right, is phenolphthalein, I guess. Okay, right, that's why the color is different. Okay, so the indicator here is phenolphthalein, right? Now indicator is phenolphthalein. Got it? Because it is colorless before. When we have a mixture of acid plus indicator, it is colorless, right? Because phenolphthalein is colorless in presence of acid. Yes or no? Right? Yes or no? Okay, right? Okay. Now what will happen? Just think about this. Think about this, what will happen? Okay, everyone, that's the concept. Don't mug up anything. Think. In this case, in this, we have acid. Means we have free H plus, right? Plus indicator. So indicator will give me the color, right? As simple as that, right? Just think what is happening here, right? Now, what you're adding? You're adding base. Means you're adding OH minus, right? You're adding OH minus. Yes or no? Right? Now, just imagine, I'm giving you a basic example. Suppose in this mixture, I'm having 10H plus, 10H plus. Just imagine, I'm just giving you a basic idea that what is actually happening. Okay, 10H plus and drop by drop, we are adding one OH minus at a time, right? One drop base means one OH minus. I'm just giving you an example. It may be more, I'm just giving an example, right? Now suppose you add one drop of OH minus. One drop of OH minus. This is 10H plus by the way. Okay? Then if we pour acid together, what will happen? Esther, I didn't get you what you're asking. Okay, right? You just said if we pour acid together, what will happen? I didn't get it. Okay, so please ask whatever you doubt you have after I explain this. Okay, right? Now just think about this. I'm having acid, right? Which means H plus. I'm having example 10 molecules of H plus, 10 H plus. If I adding one OH minus at a time, what will happen? Tell me, what will happen? Think about this. What will happen? What do you think? Yes, very good, Ragini. Very good. We just saw that. We just saw that, right? That H plus will combine with OH minus, to form H2O. Yes or no? How many of you remember this? H plus will combine with OH minus to form H2O. Yes or no? Yes or no? Tell me. Yes or no? Everyone should understand, right? Everyone should understand. Now we had 10H plus, 10H plus, and then you're adding one OH minus, one OH minus, right? So one H plus and one OH minus will combine to form one H or half H2O, right? Okay, or it form H2O. Sorry, form H2O, right? Okay, right? So we are left with 9H. plus. Okay, that's what I said. If I'm having 10H plus, if you have, right, 10H plus and you add one OH minus, we know that H plus and OH minus, right, will combine to form H2O. Okay, this reaction is called neutralization reaction. This reaction is called as neutralization reaction. Okay, this reaction of H plus with OH minus to form H2O. This is your neutralization reaction. Actually, this is your neutralization reaction. So if you have 10 H plus and 1 OH minus, right? If you have 10 samosa and 1 tomato ketchup, right? And you can eat 1 samosa with 1 tomato ketchup. Just imagine, you can eat 1 samosa with 1 tomato ketchup, and if you have 10 samosas and only 1 tomato ketchup, then how many samosa you can eat? Tell me, how many samosa you can eat? One only. And how many samosas will be left? Tell me, how many samosas will be left? 9 samosas. Easy to understand, right? Now, if I give you one more tomato ketchup, suppose if I give you one more tomato ketchup, then 8, right? Yes. If we give you 10 tomato ketchup, then, right? So after, just imagine, after I give you 10 tomato ketchup, how many samosas will be left? How many samosas will be left? 0. How many tomato ketchups will be left? 0, right? So there won't be any samosa or tomato ketchup. Yes or no, right? There won't be any samosa or tomato ketchup. Okay, right? In the same way, we have OH minus, which is your tomato ketchup. We have H plus, which is your samosa. Okay, if you give equal amount of both samosa and tomato ketchup, which is H plus and OH minus, they will combine, right, to form water. Okay, got it? Got it, everyone? Right? So after I give 10 OH minus, after I give 10 OH minus, okay, right? Both H plus and OH minus will combine to form H2O, right? Now, just imagine, after, so before 10 H plus, right? 9 OH minus, okay. The solution, what do you think? Solution will be acidic or basic? See, color will be same. Color will change after a point. That's what I'm trying to explain, right? Case one, right? You're just adding OH minus drop by drop, right? We have a case, right? Where we have 9 OH minus and 10 H plus. Okay, tell me the solution, right? Will be acidic or basic? Think about this. Everyone, think about this. Yes, very good. In total, right? Yes, in total, you have 9 OH minus and 10 H plus. So 9 OH minus will react with 9 H plus to form H2O, but you are left with 1 H plus. Okay, so I can say that if H plus is greater than OH minus, yes or no, then the solution will be acidic. Yes or no? Tell me, right? If H plus is greater than OH minus, solution will be acidic. Yes or no? Right? So the color will still be colorless. Still it will be colorless. Okay. Now if you give 10 H plus and 10 OH minus, 10 H plus and 10 OH minus, right? So H plus is equal to OH minus. The solution will be, tell me, it will be what? Neutral. Okay, neutral. The solution still will be colorless. Okay, so colorless. I'm taking example of phenolphthalein. I'm taking example of phenolphthalein. Okay, Abhinav, that we will explain. Don't worry about that. Okay. Now, suppose if I'm taking 11 OH minus, 11 OH minus, 11 OH minus, and then 10 H plus, what will happen? In this case, H plus is less than OH minus. Yes or no? What will happen? It will become what? Acidic or basic? Basic. Yes, very good. Very good. It will become basic. And what is the color of phenolphthalein in case of basic solution? What is the color of phenolphthalein? Pink, right? Pink. Got it? Now, did you get why the color changes? Tell me. You don't have to mug up everything. You have to think. Now, how many of you understood that why this color is changing actually? Yes, everyone? Everyone should understand. I have explained you on a very basic level, right? What is actually happening in the process, right? What reaction is happening? I will discuss the reaction in detail, but this is the overall idea that what is happening. Okay? Yes, very good, right? Very good. Okay, so let's come to our example. Okay? Okay. Now, let's see this. I'll just give you some more examples. Okay, I'll give you some more examples. Yes, yes. See, that's the thing. Acid and base, right, is basically, yes. So acid and base are your compounds containing both H plus and OH minus, right? The compound having more H plus will show acidic property, okay? And compound having more OH minus will show basic property, as simple as that. Okay, right everyone? Got it? Everyone got this? Tell me. Everyone got this? Okay? Okay. Okay. Yes. And if H plus and OH minus are equal, then it is your neutral solution. Yes. Very good. Very good, everyone. Okay. Now we have a question over here, right? Now we have a question over here. Everyone? Okay, this one, right? This one. What happens to an acid or a base in a water solution? Tell me, what happens? Tell me. If you add your acid or base in water solution, what will happen? Okay, before that, you should add, you know, why it will changes color, Yukti, why it will change color. Okay, right? Now just think about this. You should add water into acid or acid into water. Tell me. You should add water into acid or acid into water. Yes, yes, Ragini, very good. So we should always add acid into water. Okay, acid into water, that too slowly. Okay, right? Because it will react. If you add water into acid, it will react vigorously and even you can get burns. Okay, right? So it is advised to, my voice is clear, Abhinav. My voice is very clear. Everyone, tell me, is there any issue with my voice? Because I can hear my voice very clearly. Nothing will happen, na Ragini. Nothing will happen because it is neutral, na, right? It is neutral. Just think about this. So someone asked, what will happen if you put your litmus paper in water. Now litmus paper will change in color if there's acid or base. Yes, but obviously it will not change the color when your solution is neutral. Okay, it will be same. It won't change any color. Means if you put red litmus in water, it will be red only. If you put blue litmus in water, it will be blue only. Okay? Okay, everyone? Right? Right, everyone? Okay. Okay, everyone. Very good. Right? So this we understood that we should add acid into water slowly. Okay? Okay, everyone. Right? Okay. So let's see. So someone asked, what about other atoms? Okay. Someone asked that, sir, what will happen to other part of acid and other part of base? You know, that's what you asked, right? Okay. Very good. Now let's see. Let's see. Let's take a base. Most common base. NaOH. NaOH plus most common acid HCl. Right? Okay. Yes. Okay. Akshit, we will discuss that, right? Okay. See, because when you see this diagram, right? See this. Okay. We are adding acid into water. Yes or no? Right? This is flask containing concentrated acid and we are adding this into water. Right? This is your NCRT only. Okay. Right? So obviously just verify from where you have studied that. Now, just think about this. What it will form. What it will form. Right? You see this. See this. When you talk about acid, when you talk about acid, this is your acid. When you talk about base, NaOH is your base. Yes or no? Tell me. Yes or no? Yes. Now we know that NaOH is actually Na plus OH minus. Agree? NaOH is Na plus OH minus, and HCl is actually H plus Cl minus. Yes or no? Yes or no? Everyone got this? Yes or no? So I told you that this H plus and OH minus will combine to form H2O. H2O, right? Then we are left with what? Na plus and Cl minus. Na positive charge, Cl negative charge. So obviously Na plus and Cl minus will combine to form what? NaCl, right? Now this is your salt. This is your salt. This is your water. That's what I said, right? Acid plus base gives salt plus water. Okay, everyone? Right? So let's solve another problem. MgOH whole twice, right? Plus HCl. Tell me what we will get. Everyone, just tell me what we will get. MgOH whole twice plus HCl. Tell me, what do you think? What we will get? Okay, Madhu? Everyone should think. Now let me ask you another question. How many OH is attached with Mg? How many OH is attached with Mg? How many? 2. Okay. Yes. Very good. Very good. So if you want to replace OH and add Cl, how many Cl will be attached with Mg? How many Cl? Tell me. 2 only, na? Why 10? Why 10? We have studied now the valency of Mg is 2 and valency of Cl is 1. So if you cross multiply, it will form MgCl2. Right? We have done this. How many of you remember this? Tell me. Have we done this? Tell me. Have we done this in the first class of chemistry? Right? I hope all of you should remember this. Okay. Okay. If anyone have language of chemistry, okay, I'll send you the list of atoms. Okay. Metals and non-metals. So see, if you don't know this, don't worry. So this Mg will be Mg plus plus OH minus. Yes or no? And here we have H plus Cl minus. So you will get MgCl2 plus H2O. Agree? Yes or no? Yes or no? Yes or no? Everyone is getting this? Everyone is getting this? So this is your neutralization reaction. This is your neutralization reaction. Okay? Right? This is your neutralization reaction. Okay? Right? So I'll just write it over here. If H plus is greater than OH minus, okay, then the solution is acidic. Acidic. If H plus is equal to OH minus, then the solution is neutral. Neutral. And if H plus is less than OH minus, then the solution is basic. Yes or no? Tell me. Yes or no? Agree? Agree? Okay. Very good. Very good, everyone. So till this point, anyone have any doubt? Tell me. Till this point, anyone have any doubt? Those who missed the class for first 15-20 minutes, please watch the videos again. Okay, right? But whatever I'm just making you understand now. Do you have any doubt? No? Okay. Okay. Very good. Now I'm saying that if H plus is equal to OH minus, if H plus is equal to greater than OH minus, greater than or less than OH minus, so there should be. Okay, I'll just give you one more example. Okay, I'll give you one more example. Right? Suppose we have KOH plus H2SO4. KOH plus H2SO4. Tell me, what would be the product? Tell me, KOH plus H2SO4. Think about it and tell me. Everyone should think. See, you have to start with K is potassium. Now we know K is potassium. So it will be K plus OH minus, right? Then it is H plus, right? SO4 2 minus. This is 2H plus actually. Okay. So if you talk about H2O will be formed by default because H plus OH minus plus. Now K plus. So K is having valency 1. SO4 2 minus having valency 2. Will be K2SO4. This is your salt. Okay. This is your water. Right? This is your base. This is your acid. Now this you might not remember, but when you solve more and more of problems, you will get the hang of it because you don't know the valency, you don't know what is your metal, non-metal and all those things. That's why it might have some issues, but don't worry, right? Try to understand what is happening. Okay, right? Try to understand what is happening. That's it. Okay, right? Okay, 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 everyone. So now you got it, Tumishka, Purvi, Abhinav, Akshit. Now you got it. Tell me, right? See, OH minus should be removed from KOH. This, as more problem you'll solve. Okay. Yes, yes. Because यहाँ पे, sorry, we have 2H na, right? That's why it will be 2H plus, right? It will be. It is not balanced. We will study that later. Okay. So don't worry about the number. Don't worry about the number now. Okay, Ragini? Don't worry about the number. Agree? Okay. Right? So let's study the next topic, which is application. Application of neutralization reaction. Of neutralization reaction. Now tell me few examples. After this, after we complete this chapter, now tell me what is the first example in your daily life where you see the example of this neutralization reaction. Neutralization means to be spelled. So salt is formed now. You're not neutralizing anything. It is formed. Okay. Any example? Tell me any example. No. The first example, right? What do you do when you wake up, right? You brush your teeth, right? Brush your teeth, yes or no? Okay. So what happens here? What happens there? Tell me. Toothpaste contain base. Contain base. Okay, right? Toothpaste contain base. Now, when you eat something, okay, when you eat something, it will decay. Yes or no? It will decay. Agree? And when it will decay, it will convert into acid. Okay, right? It will convert into acid. So I can say that food, right, decay between our teeth, between if something happened. Okay, our teeth, okay, right, and form acid. Form acid. Okay. Now, when the food will decay, obviously it will have bad smell. Agree? Obviously it will have a bad smell. Yes or no? Right? And will corrode our teeth. It will corrode our teeth. Agree? Right? Yes. So what happens? We brush our teeth, okay, with toothpaste because toothpaste contain the base, right? So I can say that food decay, right, between our teeth and form acid, and toothpaste neutralize this acid. Neutralize this acid. This acid. Got it? And prevent corrosion of teeth. Okay. Or prevent teeth decay. Simple. Or prevent teeth decay. Yes or no? Or tooth decay. Okay. It should be corrosion of tooth. Fine. Agree? Yes. Everyone agree? Everyone understood this application of neutralization? Yes or no? everyone should understand the application of neutralization. Okay, right? Okay, okay, everyone. So someone asked, what is neutralization reaction? See, this is what I said. The reaction between an acid and base, right, to give salt and water is called your neutralization reaction. Okay? Yes or no? Agree? Got it? Nandish, got it now? What is neutralization? Right? Okay? Now, how many of you have heard that gas ho gaya पेट में and all those things? Or acidity ho rahi hai? Tell me, how many of you heard of acidity is happening and all those things? Right? What do you do? What do you do? When you have acidity, what do? You eat, you drink, or eat Dizene or something like that, or drink soda? Yes? Okay? Why? Tell me why? Because it contains base. It will neutralize your, not lemon, right? It's base, it will neutralize your acid. Okay? Got it? Got it, everyone? Okay? Okay, everyone. Very good. So see the reaction? See the reaction. NaOH plus HCl gives NaCl plus H2O. This is your reaction. What, Shravya? What I need to repeat again? Tell me. I just said, right, that when we feel acidity, it is because of higher concentration, higher amount of acid. So we eat, right, medicine like Dizene, or we drink Eno, right, because it's a base, it will neutralize the acid present in the stomach. Okay, excess acid. Okay, so see, right, neutralization everyday life. So first is indigestion, right? See, this is given because our stomach produces hydrochloric acid. Okay, so our stomach contain acid. Our stomach contain acid. But suppose the amount of acid increases. Okay, now just think about this. What is acidity? I'll explain what is acidity. Suppose our stomach needs 10H plus. Suppose our stomach needs 10H plus. Okay, right? But because of some reason, right, the number of H plus increased to 15, right? Okay, then what do you think? What will happen? The acidity of stomach will increase or not? The acidity of stomach will increase or not? Yes or no? Yes, right? But we need only 10 H plus. So what we have to do with remaining H plus? Tell me, what we have to do? We will drink Eno, right? So Eno will provide extra 5OH minus, it will neutralize, and again we will get 10H plus. Got it? Now you understood what happens when you drink the Eno? Okay? So see, right? See this. Eno or your Dizene, they contain antacid. Okay, right? They contain antacid, right? Like milk of magnesia. Okay. Now, how many of you remember this reaction? Tell me, how many of you remember this reaction? I just gave this reaction 2 minutes before. Yes or no? Yes or no? Everyone remember this reaction, right? Now this reaction is actually the reaction which happens in your stomach when you eat or when you drink Eno. Okay. This MgH का whole twice is called as milk of magnesia. Okay. This is called as milk of magnesia. MgH का whole twice is called as milk of magnesia. Okay. Got it, everyone? Tell me. Everyone understood what happens when acidity is increased in your stomach? Yes. Take your time. Just go through this.
Okay.
Okay, this is one example. Now, second example is ant bite. Okay, now ant contain acid. How many of you heard that if ant bite, rub it with baking soda? Tell me, how many of you heard this? Have you heard this? That if ant will bite or if your bee will bite, just rub it with soda. Okay, no, that's a usual remedy because when ant bites, it injects acid, which is your formic acid. In ants, we have formic acid. Okay, yes, or toothpaste or rub toothpaste. है ना? Right? Right? Rub toothpaste. That is common. Okay, so because this contains acid, that's why you rub base, be it baking soda, right? Or what? Toothpaste, right? Got it? Tell me, got it? Right? So I can say that when ant or bee stings, it injects acid, which is your formic acid, and we rub it, okay, by either your sodium bicarbonate, which is your base, or this toothpaste. Okay, okay, Amisha. Okay, don't worry. There'll be a video. Just make sure everything is fine. Okay, okay. It will neutralize, na Devika, right? It will neutralize. Acid will react with base, and it will neutralize. Okay. We'll have a break, everyone. We'll have a break for after this concept. Right, we'll have break of 10 minutes, then we'll play Kahoot. Okay, okay, that is our second case. So we just studied about three practical application of neutralization reaction. First, toothpaste. Second, andesite. Third, antacid. Now, soil treatment. Obviously, sometimes when you talk about soil, right, the acidity of soil increases because of excessive fertilizers. Okay, so I can say that because of excessive fertilizers or because of acid rain, okay, both, right? Soil becomes acidic, okay, and we know that there's a fixed level of acid and base in the soil, right? So plants do not grow well when either acid is more or base is more, okay, okay. So obviously we need to neutralize excess acid or base. Okay. Now, how many of you have ever visited any farm? Tell me. How many of you ever visited a farm? Anyone? Anyone visited any farm? Yes. So have you seen that the farmers sometimes they spread this tuna? You know what is tuna? Right? No, you don't know what is tuna. Tuna is your calcium oxide or calcium hydroxide. Okay, they are the bases, right? There's a white substance. Okay, it's very common. Okay, you can just ask what is tuna earlier. Okay, how many of you have used or have seen some people to whitewash your home? Tell me, right? In earlier time, like in your grandparents' time, right? They use a white substance for whitewashing. Yes or no? Right? That is tuna. Okay. right? That is your calcium hydroxide. Okay, 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 everyone. So we mix that. So the farmers will spread. Yes, bleach is something else, Abhinav. Bleach is something else. Okay, right? It's calcium oxychloride. Okay, it's something else. We'll study everything. Chemistry is very interesting. Okay, so the farmers will spread this quicklime, which is calcium oxide, okay, and slag lime, okay, to neutralize the acidic nature, and they use organic matter, okay, to neutralize basic nature, okay. So what farmers use to neutralize acidic nature? They use base. Which base? Calcium oxide or calcium hydroxide. Okay, what these farmers use to neutralize base? They use organic matter which releases acid. Okay, okay, everyone, got it? Okay, so these are some examples. Next is factory waste. Obviously, factory waste contain acid, right? So it should not be allowed to spread in your seas and all, because it kills your sea animals. Now, what do you think? What is the reason for acid rain? Tell me. Do you know what is the reason of acid rain? How many of you know this? They put organic matter, right? Okay. Tell me. Yes. See. Yes. Because of pollution, it releases acidic gases. Okay. For example, sulfur dioxide, right? Carbon dioxide, carbon monoxide. They mix with this water vapor present in atmosphere, okay, and they form acid, okay. Acid rain ether. Okay, don't worry, I'll explain. Don't worry about it, I'll just write. Okay, okay, so let's take a break of 10 minutes. We'll be back after 10 minutes. Okay, everyone, so we'll be back at 4:10. Okay, after that we'll discuss each and everything once again, and then we'll play Kahoot. Okay, everyone. Okay, okay, take a break of 10 minutes. There are many things that you have to remember. For example, sodium hydroxide, Na, which is your base, HCl, hydrochloric acid is your acid, and all those things, right? Tooth decay is caused by presence of base. True or false? Tell me. Tooth decay is caused by presence of base. True or false? Yes, very good. False, na Yukti, I just said. Right? It is because of acid. Right? Right, everyone? It's false, right? I just said, na, tooth decay is caused by acid. We use toothpaste because toothpaste consists of base. Okay, everyone? Right? Okay. So please try these problems. Tomorrow we will discuss all the problems. Then we will start the exercise. Okay. Now it's Kahoot time. Ready, everyone? Kahoot time ready? Okay, everyone. Very good. Very good, everyone. So we will play lots of Kahoot today. So we studied, we solved this one. First one, right? Okay. Ready, everyone? We will play Kahoot. Yes, very good. Let's see who will be the winner today. Okay, Shavya, I'm waiting. Don't worry. Don't worry, I'm waiting. Okay, I'm waiting. Don't worry, just join. Everyone should join. Everyone should join. Shichan, you also join. Everyone join. The code is 8127709. 8127709. That's the code. Everyone should join. Yes, I'm waiting, Mansa. Don't worry. Unless until all of you join, I won't start the game. Okay? So 15 players have joined now. Everyone, what about others? Yes, 22 members should join. Actually, 23 should join. Shichan is back now. Okay, Manita, I'll wait. Don't worry. Okay, Shavya. Only 15 have joined till now. Everyone, please join. Only 15 strengths. What about others? Everyone, please join soon. I guess only 15 strengths are there. Okay, we will start now. Those who will join late, please see the code there, okay? Manita, try to leave and then join again. No, just try to join from your web browser, okay? Kahoot.it. Kahoot.it, it. Okay, try using browser. If the app is not working, then just use your browser, okay? Okay, I'm waiting everyone, plus, but we will start within a minute, okay? Okay, 19 students have joined now. Okay, very good. Okay, let's start now. 20 students have joined. We will start. Ready, everyone? Yes? Okay. So the addition of acid and base is called dash reaction, right? It's super easy, right? Super easy. Tell me. Super easy. Yes, very good. It's neutralization. No, it's not combination, right? It's neutralization. Okay, got it? It's a specific name given to that. You guys were very slow. Okay, one question can have 1,000 marks. Second question, everyone, second question. Tell me, the product of acid and base reaction are? Super easy, fast. Very good. All 20 have answered. See, both salt and water, na? It's both salt and water, okay? Okay, everyone, next. Now, very good. Who is in the first position? Amisha in first position. Very good, Amisha. Now, it's a true or false problem. In neutralization reaction, heat is also released, right? True, na? It is true, right? That's why I told you to pour acid slowly, right? Because heat is released, na? That's why you will get burns and all. That's what I said, right? So heat is released, it's true. Okay, remember this concept. Next, in reaction between hydrochloric acid and sodium hydroxide, the product is or are? Tell me, what's the product? Fast, everyone. Fast, but don't be hasty. Okay, your answer should be correct. Okay, I got 19 answers till now. It's both sodium chloride and water, na? It's both sodium chloride and water. Okay, so let's see the podium. Let's see the podium, everyone. Daksh third, very good, Daksh. Very good. Who's second? Madhur is second. Good. First, Amisha or Abhinav? Abhinav. Fourth, Harsha, and fifth, Shavya. Okay, Mansa, don't worry. Just go through the problems, okay? At least you should attend. Otherwise, marks will be given on the basis of this. So let's play another Kahoot. Yes, everyone? Other Kahoot? Ready? Okay, very good.